Welcome to LIS754 Systems Analysis and Design, and in this session we are going to talk about the ways that systems analysts and systems designers can mitigate the threats to a system. In previous videos we've talked about the security triad, the three components that comprise security: confidentiality, integrity, and availability. We also use that to talk about the threats, that each of those components has specific threats associated with them. And in this session, we're going to talk about the mechanisms that we can employ to enforce those security mechanisms. Confidentiality is enforced by the access control mechanism, that is, who can access the data. Integrity is enforced by access control mechanisms as well. Again, who can control that data and update that data. And by semantic integrity. In previous sessions in this course, we have talked about error processing, making sure that the data is correct when it comes in, what we can do programmatically to make sure that data is right. And we are not going to continue to cover that in this session. So if you have questions about that, go back and look at some of those other sessions where we talked about edit control and masks and various ways of designing systems so that the data has integrity. Availability is enforced by recovery mechanisms, so making sure that we have backups so that if data goes down, data gets corrupted, we can go back and get that data from tapes or other copies of the data that we've had, and for detection techniques for the kind of external attacks that get perpetrated on systems, denial of service and other types of attacks. But what we're going to primarily focus on are the things that we can do within a systems design, which is access control for both confidentiality and integrity. And both of those then again have impact on availability. When we think about access control, we think about there's two primary components of access control. There's user authentication, and there's user authorization. And unfortunately, those terms are very close. They sound very similar, but they mean really different things. So user authentication is to verify the identity of people logging in. You are who you say you are. You are who you say you are because you know the right information. User authorization is tells me what I'm allowed to do as a user. So, can I look at this data? Can I update this data? We have other mechanisms. Encryption is a way that we can protect information. We run some statistical or some numerical processes against the data. We transform the code that is used for that data into different codes, and that's how we can protect data. And we've talked about a couple of those examples of why encryption could be really helpful. And intrusion detection, protecting against impersonation of legitimate detectors. And so we can have software. We can generally buy software that can do that, or have software across all systems within a large organization to protect against that. For this session, we are primarily going to focus on access control. And what does that mean? User authentication and user authorization. So as we mentioned briefly, authentication is the process of verifying identity. I claim to be Stacy Kowalczyk. How does the system know that I am who I say I am? And we have this is a two-phase process. There's the username, so we have an identification step where I type in my username or my login ID or whatever. There's a couple of other terms that you could use for that, but username or login ID. And then I have some kind of a password, some kind of a way to authenticate my identification. And we can do that in a couple ways. We can do it with, the most traditional is a password. I have to know a specific sequence of characters to type in. That has been prearranged. So when I set up my user ID, my account name, I have to tell it what word I'm going to type in. Sometimes these passwords can have very strong rules. When I was at one university, we had to use a passphrase. It wasn't a password. It had to be 4 separate words separated by blanks. They had to be words that were recognized in the dictionary, and there was at least one of the words had to have a number in them. I know, how very odd is that, but very, very strong words, or very, very strong rules for how I could set my password up. Authentication can also be a physical thing, like a badge or a smart card, some kind of a card with a code, some kind of a code that's built into an object that the computer can read. So sometimes I can have a QR code or a barcode that's my equivalent of a password, a physical object. Sometimes it is who I am. Sometimes there's biometrics, fingerprints, retinal scans, those kinds of things for really secure systems. And sometimes it's where I am. If I'm in front of a particular terminal, I take on specific user identity. So this happens a lot in public kiosk kinds of places. So if I'm at like in a library, the front circulation desk, whoever is at that terminal, whoever is using that computer, takes on the role of a circulation clerk. So there's ways that we can have it be tied to a physical place, where it's tied to an actual person, the biometrics of a person, where we have it be a physical thing, or a piece of knowledge, a password. There are problems with passwords. Really, people pick easy ones. In fact, for a long time, you would, when you installed a LAN in your own house, when you set up your Wi-Fi, you would get the password was set to password, and no one ever changed from the default word of password for the password. And companies like AT&T and Verizon and all those organizations have stopped using password as the default password, since nobody does it. Now you get a long string of characters and numbers. But people pick really easy to guess words. Account names. So if you're email, like a Dominican, our IDs are our email addresses, right? So SKOWALCZYK is my ID. And many people will use that same string of characters, their account names or usernames, as their password. Well, that's a problem. Sometimes they name it for places or birth dates or kids' names or dog names. I love you, those 3 words, I love you, is one of the most common passwords. Who knew? If things are letters only, it really makes it easier for someone to guess those. License plate numbers, acronyms, social security numbers, really a bad idea to use your social security number as a password. The other problem is that many systems do not require passwords to be updated on a regular basis. Now, Dominican does, which is a really nice thing. Other places I have worked large organizations have required that, although I worked at a couple that didn't. So, failure to expire a password or failure to require for an organization to require passwords to be updated is problematic. We want to make sure that passwords are safe. So having a combination of letters and numbers and special characters makes it harder to be hacked, makes it harder for people to guess what they are. Your security access control is only as good as passwords can be. So enforcing strong rules on passwords is important. Security is enforcing security in a system requires 3 components. First, you have to have a security policy, a mechanism to enforce that policy, and then a way of assuring that the mechanism and the policy are sound. So what does this mean? A security policy says what is and is not allowed. Security, it defines security for that information. So let's think about what that means. In our payroll system, we want to know who can see the salary information. So the employee should be able to see should be able to read their salary information. The hiring manager should be able to see the salary of the employee. The HR manager should be able to see and update the salary information for an employee. So those are examples of what a policy could be. And then a mechanism enforces that policy, right? So we've talked about that. And for this, it would be based on access control. The mechanism for those policies would be access control. Now, if we created a security policy for our entire organization, we would want to have, it would be broader than that. Within the system, we're talking at a relatively granular level. At an organization, we talk at a pretty gross level, a pretty big level. And that would include things like doing a risk assessment of all of the data, a risk assessment of all of the systems, password policies, who's responsible for administering these kinds of things, what's the responsibility of the user, dealing with things like email, internet, etc. But for us, within our system, security is access control. What we can control as systems analysts is access control. And so we do need to do a risk analysis. We do need to assess the risk of components, which data is the most important, which data needs the highest level of security, what operations need the highest level of security. And then we want to minimize the exposure of that data, minimize the exposure of those operations. So which people can access that data, which processes can access that data. So again, if we're thinking of our payroll system, and we're talking about salary information, there are going to be, besides the people who want to see that data, there are processes that will want to see that data. So if I want to get a report of the salary, a weekly salary expenditures for the entire organization, there's going to be a process that needs to be given permission to look at the salary data. And then who is going to be able to see the outcome of that salary summary? Now, if it's kept as a summary and everything's anonymous, there's less necessity to highly control the access to the output of that process that would do the summarization. Nevertheless, we need to be thinking about people and process, the needs of those, I'm going to start that again, the needs of people and processes to access data. The problem is that the more complicated your security policies, the more granular your security policies, the more difficult it can be to administer those. So who's going to be the person that says, Stacy can access the salary information of these people, but not those people, that this manager can do these things? It starts to get really complicated. So one way that we can try to simplify the administration, and the more complicated the administration, actually the less secure a system can be, the more likely an error will be introduced into the management of the access control. So we can simplify the administration of our security policies by creating security groups, grouping people with like needs and having the security controlled that way. And so let's look at access control in general, and then we'll work towards what those groups would be. So this is a model that is still used very widely in information systems, developed in 1994. We think that there's a lot of improvements and changes in information technology, and there certainly have been, but there are some things that work the same way that they did in the 1970s as they do today. And access control models is one of them. We have a subject, so a person or a process that needs access. They request access for that data. There is a process, I don't really like this name of reference monitor, but this is the name it was given in 1994 and often still continues today. A reference monitor will grant or deny access to an object, to a chunk of data. So the subject is an entity that performs computation. It can be a person, or it can be a computer that is processing programs. When we think of people, we can think of individuals connecting to the system, and we call those users. You can group sets of users together, and often those groups of users are based on roles, a collection of privileges or functions within the organization. And so in a library, you can think of things like a circulation clerk or like a cataloger. In an educational setting, you could think of users as students, groups and roles as students, principals, teachers. In a business, you could have employees, managers, senior executives, or you could have data entry clerks and payroll clerks and billing clerks, all as separate roles. It depends on the nature of the business, it depends on the nature of the system, and it depends on the sensitivity of the data. So this is something we're going to continue to think about. Okay, so we've had subjects. We're going to talk about operations. Operations are processes that subjects exercise on objects. The type of operation corresponds to an access mode. So access modes can be things like reading, writing, executing, selecting, that's a specific term for a database, inserting, updating, deleting. And one of the most common models for expressing an operation is called CRUD, C-R-U-D, create, read, update, delete. It's really succinct, it's memorable, and it is universal in its application. So for our systems, we are going to think about these operations, creating, reading, updating, and deleting data, and how that works into a security policy for our systems. Right, so let's go back. So we're thinking about subjects, requesting access to do on an object, and this access really assumes an operation. It assumes an operation. Right. Create, read, update, delete. So we have this little model. We have this idea of authorization and access control. So how does this work? Basically, we set up a little database, a little table that gives us permissions, that has attributes about the subjects and objects, and we create a little matrix of actions, our CRUD, right? Actions are CRUD, the create, read, update, delete, subjects, people, and objects, data. So we create a little matrix that says for user group type A against this type of data, these are the objects that are, these are the actions that are permitted. So employee can look at their own salary. Hiring managers can read the salary information of their employees. A HR manager can look at all employee data. So this is how this works. We have users that are gathered into groups, and those groups have access to objects. Their groups are just this interaction, and it can be positive permissions. You have permission to read and write. You don't have permission to delete, if that makes sense. So let's think about our payroll example yet again. So we have data in our system, the working hours, the tax rates and rules, wages, and we are going to have people who are going to want to update those. We're going to have people who are going to want to view wages, view tax rates, view department weekly wages, view multiple department weekly wages. And we're going to have different user groups. We have employees, managers, payroll clerks, payroll manager, and a senior manager. And we can put this into a matrix. And so for my matrix, I put the employee, I put the groups, I put my people across the top, and then the operations along, the actions or operations along the side. And then working hours, an employee can, well, I think that's wrong. For working hours, I should be able to, as an employee, create the working hours. I need to type in, if I'm a salaried person, I need to be able to type in that I worked 8.5 hours today. I worked 7 3/4 hours yesterday. I want to be able to create that data. I want to be able to read the data that I put in. I'd like to be able to update it and delete it if I need to. The manager should be able to read it. A senior manager shouldn't be able to do anything with the hourly staff's working hours. The payroll clerk should be able to read and update it. I would like the payroll clerk to be able to update it in case I submitted my hours and found that I had a mistake. Oh, rats! Rats, I meant to change something. So the payroll clerk could go in and fix it. And the payroll manager should be able to read and update and delete. And perhaps you could argue that the payroll clerk and the payroll manager should not be able to update the data. You could argue that, and it would be completely reasonable. You'd have to have some override mechanism, though, for fixing an error, because now we've got integrity issues. So if there's an error, it would need to have, there'd need to be a process by which the payroll clerk would be able to override the hours of the employee. You would not want the payroll clerk to override them. Tax rates. The employee should be able to read the tax rate. The manager should be able to read the tax rate. And I should have put that the payroll manager should be able to create and update the tax rates. Right? So in this case, this is something you'd want to notice, that if somebody has to be able to create and update these. And it is a missing policy that would need to be added. The tax rules, the senior managers might want to know the tax rules. The payroll clerk might need to know the tax rules, and then the payroll manager would need to be able to create, read, update, and delete, etc. You can go through the whole process like this. The department and weekly wages, the multiple department weekly wages, these are reports, and who is going to be able to read these reports? The employee doesn't necessarily need to know them, but these are read-only. This report and these people need to read these objects. Now, anyway, this is how this should work. So what I would like you to do for your system, many of you have already started to think about authentication in your use cases, in your workflows, in your process diagrams. You talked about authentication. If you've done that, terrific. You don't need to do much more. You might want to just reinforce the password information. Make that a little bit stronger. Some of you already have strong enough, but think about the authentication, the password rules for your system. But for your system, I want you to think about authorization. Who is going to be able to update what information in your system? I want you to create security and access policies, groups / roles, and think about this subject operation object matrix like we created here. I would like you, for your system, to be able to create a matrix like this. So we have multiple components that work together to create security within a system. We have authentication, ensuring that the people who are signing in are actually the people that we expect them to be. We have authorization. We have a way of allowing people to have access to certain parts of the system, to certain data elements, depending on who they are. We have, we take those two things, the authorization and the authentication, and we create policies that are based on that person, the subject, the operation, what people are going to do, and the object. And we were going to create a matrix out of that. And then our software that we will theoretically build at some point uses that matrix. It enforces the rules. It logs and audits that access. So every time that an employee accesses their hours, that's logged. Every time a payroll clerk changes the user hours, it's logged. And when that's logged, that's one of the components of the auditing system, is one of the components of that detects unauthorized users. Excuse me. So we need to build these into our software. They don't have to necessarily be part of your this gets built into the software. This is what you're doing for the assignment for the week. You're going to build this matrix. Let me know if you have any questions. Talk to you soon.